Hi, my name is Saad Hassan and I'm an assistant professor at Tulane University. This paper that I'm presenting today is called Designing and Evaluating an Advanced Dance Video Comprehension Tool with In-situ Move Identification Capabilities. This work was done in collaboration with my student Will and collaborators at Rochester Institute of Technology including Caluã, Laleh, Garreth, and Briana. Dance is a popular art form characterized by aesthetic and often richly symbolic body movements. Since many dance styles incorporate intricate techniques, expressions, and formations, dance learners need to engage in imitation, repetitions, mental simulation, practice, and extensive performance observations. An important first step in dance learning is often the analysis of movements, which can be achieved through dance videos. Now, certain dance forms such as ballet, Bharatanatyam, or hula sometimes adhere to pre-established glossary of moves, prompting learners to focus on identifying sequences of named dance moves. Some digital resources for these forms often offer comprehensive video catalogs that include formal names, metadata detailing associated properties like length, type, origin, body parts involved, and significance. However, the challenge arises when users seek to identify an unfamiliar dance move using digital video catalogs, as it necessitates specifying various properties. For individuals immersed in video-based dance learning, this would involve stepping out of the context of video watching and selecting filters to uncover the desired name or information about a particular dance move in these video catalogs. In recent years, advancements in gesture segmentation for complex movement sequences in related areas suggest that search systems that use video as their input might become a reality in not too distant future. While previous research on tools for dance learners has introduced automatic choreography tools, annotation tools, and archival systems for various dance form styles, there has been a gap in exploring how to design these future systems that could potentially enable dance learners to utilize a video sample to search for an unfamiliar dance move sequence. These systems could potentially be used to streamline the experience of dance learners, especially for those dance styles that adhere to defined movement glossaries. To better understand what design parameters would best work for this use case, we have developed and evaluated an advanced video comprehension tool that features an automatic dance move identification functionality. In this paper, we report two studies. We first conducted an interview study, which motivated the design of our tool, and a final evaluation of the tool for a specific dance form. Our first research question was, what are the experiences and challenges of dance learners who watch videos to write notes? To answer it, we conducted a semi-structured interview study with 12 dance learners. The interview consisted of two parts. We used the story interview technique used in prior HCI literature on dance to understand the prior dance experiences of our participants. In the second part, we focused on their approaches to video-based dance learning, how they memorized and recalled dance sequences, and took notes on videos. We conducted a thematic analysis and report findings. Participants mentioned their experiences and current workarounds when trying to use videos for dance learning. For example, D1 said, instead of teaching the whole thing in one go, they'll teach you little segments so that it's easier to remember and you kind of just keep building on top of it. Our participants also talked about note-taking as a method for learning dance. For example, D8 said, it was a mixture of names of the dance moves and then stuff in my own words. That wouldn't really make sense to anyone else. And then another thing was to draw the formation that we were in. So they would put X's on pieces of paper and then label which one was whom. So you kind of remember where you were as well. Our participants also talked about the importance of identifying and naming isolated dance moves. For example, D8 said, there have been countless amount of times I've taken written notes, which seems like it wouldn't be the case. But in ballet specifically, it is one of the most important parts in the names of the moves, and they're all in French. One of the moves is called pas de chat, which means step of the cat. It makes more sense because the moves have a name for a reason. It correlates to me, helping me remember moves when learning. Findings from the interviews inform the design of our system. The interface of our system is organized into 5 main sections. In the top left corner, you will find the annotation interface, which includes a text input box for participants to describe the video. Below is the search results box, which displays relevant results based on the selected video portion. On the right side is the dance video itself. Below these components lies the timeline interface, which offers a visual overview of the video. Screenshots mark distinct moments, and a vertical white line, our playhead, allows users to navigate through the video. An essential feature of the timeline interface is the span selection, represented by the sign rectangle. This not only aids in the searching, but also facilitates timeline annotation. Further down, we provide playback, annotation, and search controls, including play and pause buttons, an annotation button, and one for playing the video within the current span, and another for searching dance movements based on the selected span. Let's now focus on interacting with the span selection represented by the rectangle with sign borders. This rectangle can be adjusted by dragging its start and end to customize your viewing experience. Notably, selecting a small portion and hitting play selection will restrict the video playback to that specific portion. Clicking Add Annotation opens a text box centered within the current span. This allows you to take notes specific to a particular moment. Importantly, clicking on the annotation adjusts the span selection to match the boundaries set when the note was created. In this Wizard of Oz prototype, each video has been manually annotated. The search function uses currently selected portion of the video as the input of movement searches. The results include both dance movements that precisely match the input video and that those are close but not perfect matches. Importantly, the top result is not guaranteed to be the closest match to the selected span. This approach simulates expected performance of a machine learning model that is capable but not perfect. Next, we were interested in evaluating our tool against existing digital video catalog approaches that were mentioned earlier. We adapted our tool to a specific dance form, Cuban salsa. We ask, in a comparison between experiences of users who performed a series of dance video annotation tasks using a video comprehension tool with dance move identification capabilities versus an online catalog of dance moves, is there a difference between task performance and workload? How did the users make use of system's features? And what challenges did they still face? We conducted a within-subject study with 8 participants, where they utilized our dance video comprehension tool and baseline consisting of an online digital catalog and video player with all the features of our tool except the auto-identification feature. Each participant wrote notes for 3 videos under both conditions. With the help of an expert choreographer, we evaluated their notes quality. They also reported their workload. The tools automatically logged their interactions with the system, and a researcher also took observational notes and conducted a post-experiment interview. These were our 2 conditions, so our dance video comprehension tool versus a baseline consisting of a video player with all the features and an online video catalog. We found that the quality of scripts, as adjudged by an expert salsa teacher, was significantly higher, and participants reported better subjective performance and lower frustration when using our tool as compared to the baseline. As expected, we also noticed that our participants used the span to divide the video into different segments. We also saw that many exhibited a fine-tuning behavior where they would make many small adjustments to a span position and length before invoking the auto-identify function. These figures included in the paper show the start and end times of spans selected by different participants when they used the span selector. The utilization of the span selector varied among different participants, as demonstrated in this figure, where we highlight 2 distinct usage patterns. Both P14 and 17 were aware of and actively used the span selection. However, P14 primarily employed it as a tool to limit the search input, whereas P17 not only utilized it for this purpose, but also extensively employed span selection to constrain the playhead movements as well. Based on the findings from our 2 studies, we present 5 design recommendations. Timeline-based video annotation has been previously proposed in the context of annotation frameworks for generating reliable ground truth datasets for dance video recognition. We suggest integrating a timeline-based video playhead that showcases sequential captures extracted directly from the video. Unlike a standard sequential timeline, the playhead empowers users to examine specific segments of the entire video, iterating over different self-constrained sections for a detailed exploration. We propose incorporating 2 note-taking features within the timeline-based video playhead, one that attaches a node directly to the timeline, and another for general note-taking. Additionally, we recommend a mechanism to automatically transfer metadata from the auto-identified dance move into the timeline annotation. We recommend that comprehensive metadata encompassing aspects such as difficulty level, engaged body parts, similar dance moves, and the number of dancers involved should be readily accessible to users in the result snippet. We also recommend adding textual descriptions of the dance move using standardized numbering or other established conventions to systematically break down each step into individual moves. Finally, whenever possible, video showcased in the results should offer footage from various angles. In addition to HCI and dance researchers, our findings inform developers designing interactive tools for dance learning. Our findings provide evidence supporting the integration of a span selector to refine and analyze videos, offering insights into the potential usage patterns and suggesting design recommendations. For computer vision researchers, we introduce a novel task involving a user-selected segments as input for automatically identifying dance moves according to a predefined glossary. To learn more, please feel free to reach out. Thank you.